Welcome everyone, my name is Chris and today I will be talking about our migration project. It was cast.de, which we migrated from a custom system to Liferay DXP earlier this year. Let me start with one slide on our customer itself. The Konrad Adenauer Foundation is a political foundation in Berlin operating worldwide. The project we migrated ended up with 3 GB of SQL data and 250 GB of files, which I would consider a moderate Liferay project. And we do have content delivered in 35 locales, languages worldwide, and via 150 independent sites, mainly foreign offices of the foundation worldwide. For example, there's one in South Korea, I think, 2 in the US, and so on. And they are managed by different teams on site. My talk is only the first of 2. The second one will be coming up right after the lunch break. It's in Blue Hall by my colleague Michel, where he will be talking more about the project itself. That means what this amount of data actually means, how we migrated it, what problems we encountered and how we solved them. Meanwhile, I will be talking about, for one, teasing his talk. Secondly, talking about a small change to Liferay's web content we implemented. And finally, an issue with Liferay's use of Elasticsearch, which, well, is good that the previous talk was about Elasticsearch. Let's go on. The core requirements for this project basically came down to three things. For one, we wanted to use Liferay's standard elements as far as we could. That means, if possible, we should reuse existing built-in features, existing built-in entities, and only extend where really necessary. Because, secondly, we had 2 other big constraints. For one, we had to migrate everything. That is 200,000 articles. And we had to keep all URLs working the same, as in there was just a DNS switch, and the site had to be usable the same as before. And finally, we had a fixed go-live deadline. That was the 26th of October, so we have only been live for about 2 weeks. We've started up a little before Christmas, so we ended up with 11 months of work on this project with 200,000 articles. This had to cause some problems we encountered. And, well, let's start with the old system. The old system is called WebFriend. WebFriend is a custom-built CMS for this customer only. It's written in PHP and uses some SQL statements to query data from the database and uses XLST to, well, show this data. And with a system that was custom-built for a customer who has, well, it's a political foundation, so they don't know exactly that much about technology or software maintenance or anything like that. So it was mainly smaller changes to the CMS itself, new entities that would be implemented. For example, if only some small field would change, they would just implement a new field in the database, add new forms to the front end via new code, and this continued on for basically 2 decades. So this is not a perfect system, and the most logic is hidden in the source code, which brings us to our first problem. The source code, including the SQL statements that actually, well, show data and decide what data is actually shown in all lists, we didn't have access to that. We only got the SQL dump itself and the public website. So from an early standpoint, it was clear to us that we had to reverse engineer the whole site. But at least we got the SQL statement, the SQL dump. And, well, let's look at that one. It wasn't very optimal. On the first day, we tried to use, well, tools like Enterprise Architect to reverse engineer a schema of the whole dump, which was pretty big. And we immediately thought that, well, we are too stupid to use Enterprise Architect because, for one, there are no foreign keys in this whole database. This turned out to be real. There are no foreign keys. There are still references between web content, between contents in this database, but they are mainly based on, well, one magic number describing a table and also an entity and the primary key of this entity. And that's a big table. And this contains all the relations between two entities. Perfectly. Second weird thing about it all, the primary key is not only a number. In this case, it also contains the language itself. For example, there's actually two different entities in the system for example, for every translated content. This gets even more extreme in cases of the draft state, which in Liferay is a Boolean field, saved, for example, in the journal articles or in the asset framework. In this case, it's also a field in the database, but of course, it's also part of the primary key. So we actually have copies of articles that were draft and were published on later on. So you actually have both entities in your database, and they are distinct because, well, it's a different primary key. And the last weird thing about it all was that there's no correlation between the page hierarchy, the navigation hierarchy, and the content hierarchy. The last one is basically clear because modern CMS systems often have, well, content. They are content management systems. So they have content, and they have some way of showing this content in pages. So you have pages in Liferay. They are enriched with portlets, and later on widgets, and now fragments. And those widgets, portlets, they reference some content and show them. But the page hierarchy and the navigation hierarchy in modern CMS systems are one and the same. So you actually have the navigation your site has is basically just, well, some kind of explorer view of your page hierarchy. This is not the case in WebFriend. WebFriend is basically just has a collection of links that, well, model some kind of navigation, but those links are not even attached to the page itself. And they do not have to be a tree or anything like this. They are only attached to the content. So there is some table that actually says, well, this content of type this and this has some subsite links to X, Y, and Z. Perfect. All in all, this does not help very much. We still ended up using trial and error to reverse engineer the whole thing, which brings me to our architecture guidelines, our base core principles. For one, we wanted to have automated, repeatable migrations. That means not only building our tools and our services, but also doing the whole migration via one command line script. There was a bigger talk on this on the unconference, which was about site initializers, where, well, it came up that there are a lot of different possible different implementations of, well, bringing content and configuration into Liferay. We also built our own system for that. More on that in the second talk by Michelle. We also decided to use Docker, not to help us, but to actually enforce this, because if you can write your whole migration to be fitting into a Docker image file, it will be repeatable, it will be automated. So this is some kind of, well, it does help you with onboarding later on, but it also enforces you to use some sense and always prepare automated migrations. Secondly, we do use only OSGI declarative services as any DI framework. That means we do not actually use any other things like Spring or anything that rewrites code. So all our services and implementations are dealt with via OSGI and DS. Thirdly, if necessary, we do want to use Service Builder for our persistency layer and generate necessary entities via Service Builder, so we don't actually have to implement our own persistency layer or consider writing our own code on this. Because remember, we only had 11 months, and this deadline was fixed. So do it the fastest way you can think of. And finally, the fastest way we would come up with was using Liferay's structured web content. And this brought us to our core principle. If possible, use Liferay structured web content to represent any entity you consider or even encounter. The old database had about 80 different entities. Most of them were identical or nearly identical, so we boiled them down to 20 different web content structures in Liferay. Let me just take a small reminder slide on what structured web content in Liferay actually is. You do have some kind of entity system, for example, this class diagram, which just models, well, a publication and a person, and also some kind of images. And you have some fields, for example, the subtitle or the date, the publication date of this publication. You have references to other web content, for example, this author, arrow, signaling a reference in this class diagram. You actually have nested elements, for example, this content block, which is not correct UML notation. It would be a composition in this case. Well, everything is cool, nice, and all. You can basically use structured web content to build up a definition of a class, basically. And Liferay will generate their own forms to support, to enter data, to update data, and of course delete it. And well, you also get all the benefits of using web contents itself. For example, the asset publisher will automatically work. You can use references on, and so on and so on. But there are two things you cannot actually do with structured web content if you base it on some UML class diagram as a requirement. For one, there is no inheritance in structured web content, which is actually not that bad. You can actually use composition for basically all use cases where you would use inheritance. Look up domain-driven development. Game developers, for example, never use inheritance. So this is still something that can be worked around. But secondly, there's a small issue we noticed. This author reference to persons cannot actually be modeled in Liferay. You can enter references between web contents, but you cannot actually limit this reference to only be allowing persons. If you just create a new web content structure and add a new field, for example, this author field, you could enter any kind of web content. It's not limited actually to any, well, in this case, it's called a structure name or class type, as the asset framework calls it in the API. So this was the first step where we thought about it, and well, let's extend this. Let's add a small change to Liferay, the smallest we could think of, to make those references typed. This is a generated backend form for the structure. So if you have some kind of reference fields, it will create up this select button, which, if pressed, opens a pop-up, and this pop-up contains the so-called asset browser, which probably everyone has already used. But, well, the name for this thing is asset browser, if you want to know. The asset browser browses assets. In this case, it uses basically an ElasticSearch search statement to filter all your possible assets via class name. For example, only show me journal articles, because Liferay already implemented this part of the select process. The select button only allows you to select specific web contents, not, for example, not any other asset. There's a second one for documents and media file entries, as in DL file entries. So this works basically similar, but you do not actually filter by class type, for example, actually the structure key. There's a small extension we added via JavaScript on the left side. We just injected some kind of some small JavaScript function that is called whenever this form is generated and the button is actually pressed. And we also used, well, you can create your structures however you want. You can set the attributes however you want. In our case, we use the name attribute of the from field, which Liferay actually doesn't use besides as an ID. So it only has to be unique. So we added a unique prefix for every possible structure, which in this case was also the name of the structure. And this JavaScript we injected actually looks into this field, looks up the name attribute, which is in the HTML, but not actually visible to the user, because the user only sees this label field. And if it finds this prefix, it uses it and sets it as an URL parameter to the pop-up call that is triggered when you press select. And the next step is just, well, a small OSGI fragment on top of the asset browser. You look into the current URL that the asset browser was called with. If you find this parameter, you extract it, check if it's actually a legit class type, and you add it to the ElasticSearch query that's hidden inside the asset browser's render method. And if you do this, and this field does contain the prefix, for example, persons, the asset browser will only show you persons. And this basically means that the reference, for all intents and purposes, becomes a type reference. So the target will always be of one type. This is, well, just one small example of things we changed. I did cut up a lot more. You will see some more information on the second talk. For now, a small other trick, at least, we used. We already decided to mainly be using journal articles, as in web content. So we also wanted to normalize our use of portlets. So we ended up using asset publishers and asset publishers only. And thanks to a lot of pages we had, we ended up with, well, the number is wrong. It's actually 10,000 pages and about 50,000 asset publishers, something like that. But that allowed us to only be using asset publishers, so configuring them was easier. And we did end up using 64 application display templates written in FreeMarker to customize the way they actually show data. To manage 64 ADTs and so many asset publishers with a fixed go-live date, you always will be ending up using a lot of time for, well, duplicated code you actually have already written but don't know about it. So we decided to put the main logic of all those ADTs into FreeMarker function calls and macro calls that are actually stored in the theme, because we only have one theme. The theme is always available if it's visible. And so it will compute those macros, make it available, and every ADT can actually call them, because in the end, those ADTs are actually just called as sub-functions to the theme if you do look at lifeless rendering. Secondly, one further step, we did intend to use this front-end service and, well, ended up using it. This front-end service is just an OSGI service that is used by the front-end, but it's actually the only OSGI service the front-end is using. So this allowed us to split our team into two parts. One would be implementing the theme and the ADTs, but they would only be accessing any data or inputting any data via functions by this front-end service. Every function in this front-end service is well documented, strongly typed, well tested, potentially cached, and so on. So it's basically best case code you can think of. And it actually hides every access to Liferay's API, to ElasticSearch, or to our custom business logic. Which brings me to the last part of this talk, where we actually used ElasticSearch. I will be skipping about some slides because, well, the previous talk was actually explaining some of them. For one, we ended up developing our own search portlet. If you remember, this was a 7.0 project. This previous talk was actually explained how the new 7.1 search is split into widgets, and you can customize those widgets. In our case, we had some special requirement. Our search should work via finding content by references. So if you look up some person, for example, Bob, you will not only be finding Bob, but also all articles Bob wrote or all articles that reference Bob and so on. So this actually was implemented easily by just inlining fields inside the Elasticsearch index, but we had to customize our search query that actually the search portlet creates or uses. So we did end up just creating our own custom portlet, which is easy, but, well, probably unnecessary now. Secondly, there are still some use cases. For example, this front-end service also computes dynamic data queries, which you often have. For example, we had some recommendations that are basically just articles, the newest articles that share some categories with the currently portrayed one that is visible to the user. So this has to be evaluated at every call and every page load, because you cannot actually cache the results for a longer amount of time, because oftentimes you have multiple new articles on the main site per minute. So our customer puts a lot of content out, and we do have to dynamically generate those recommendations every time the page is actually loaded. So this is something that can be done via the API, via database queries. For example, the asset query or the dynamic query will easily be capable of doing this thing, but it will be operating on the SQL server, and, well, it already has to do a lot of other things. So we did decide to bring this whole data query stuff over to Elasticsearch. Elasticsearch does not actually have to do a lot of things in most cases, because Elasticsearch is optimized for high performance, and most Liferay sites are not the scale of, for example, the Google website. So you do have some additional space to distribute load onto the Elasticsearch server. And finally, well, you can actually customize the Elasticsearch index by introducing new fields. And if you do, the asset publisher has a nice, well, a nice feature, because it actually is just an Elasticsearch query with a nice front end. So it filters by some fields in the Elasticsearch index, and it sorts by some other fields. And the whole configuration of the asset publisher is just, well, hiding this whole thing that you actually just have reference fields by name in the Elasticsearch index. And if you do introduce your own fields, as we have done in some cases, you can just configure your asset publisher to be filtering on those new fields. For example, we have this need for A to C glossaries, which just take a lot of articles on a specific structure, and you only want to show, for example, in one tab, you want to show only articles starting with A, and the next only articles starting with B, and so on. So you can actually extract the first letter, write it into the Elasticsearch index, and the asset publisher has to be configured to be only reading this new field. And you can just say, well, now this asset publisher filters out or just portrays those articles that actually begin with A, which is a small use case, but not actually something you can do with out-of-the-box Liferay asset publishers. I will be skipping this next two slides, because this is just the index of post processor. The previous talk was teasing it. This is actually in the Liferay documentation. You can actually just create this new the implementation for this interface, and you can override the documents that Elasticsearch indexes before it's sent to Elasticsearch. You can enter new fields, you can delete all the fields, and so on. So this is actually very simple, and, well, it's in the Liferay documentation, so great thing. Also, another thing, if you do want to write some custom queries, there's also documentation on how to build search queries using Liferay's search API, which basically, well, very closely mirrors what Elasticsearch is actually capable of. Liferay's documentation on this is actually pretty good, and Elasticsearch documentations is even better, so please look at them. But there's one last thing we did encounter, and this is, well, Elasticsearch still has limits. And I'm not talking about, well, if you do create cross-region clusters or anything like this, you actually have some real, well, even with one simple server, you still have some issues, or at least some limits. For example, by default, every field in the index is limited to being only 32 kilobytes of, well, string data. So if you have more than 32,000 characters in your strings, it will not actually be indexed. You can tell Elasticsearch to, well, just skip everything beyond this. But Elasticsearch has to set some limits because it internally builds an index to search on the string, and you cannot actually support larger strings easily. So a good use case or a good solution, if you have longer strings, just split them into two fields. You can do this via this indexer postprocessor I just showed. If you do find a string, just call in string length bigger than 32,000 and split them on demand. This works. Secondly, there's of course, a hard limit on the number of documents Elasticsearch can actually store, and this is 2 billion per shard, which sounds like a hard limit, but 2 billion is still a lot of things. So we have 200,000 articles for our customer, so we still have a lot of space left. And there's also not really a limit on how many shards you can actually have in your whole cluster. So even on the same machine. So this is not really an issue. You can just store as much data as you want into Elasticsearch. But what you cannot do is having unlimited number of fields. And fields, well, if you think about the Elasticsearch index, it's basically a table, and I do want to show it in this example. This is a simplified version where you have the two fields. First, UID and type, which is, I consider the meta fields, followed by title EN, title DE, title NO, because I also know Norwegian and I had to use 3 languages. And there's also the second field, which is description EN, description DE, description NO. So this is the example that you have, some kind of web content structure that has 2 web content structure fields, and you have 3 locales. And Liferay will generate a custom field per locale and per field. And this, in our case, we had 20 structures, as I've said before, with around 15 unique fields each, which makes 300 fields. And now we also have 35 locales. So Liferay actually creates 10,500 fields in the index just for our web content structures. This is too much. We did end up having to configure Elasticsearch itself to allow this amount of fields. It does, it does not help your performance, and it will not make it much. It will not be very stable, but it's good enough for us now. But there's, of course, one solution would be to change how Liferay actually does this, and this is an idea by my colleague Christoph Marketsmüller, which is here and probably anywhere back there. So you can actually just, instead of duplicating the fields by the number of locales, you can instead just create copies of the Elasticsearch document and create new documents for every locale. So this is basically what WebFriend's database does. You actually add the locale to the primary keys. In this way, you do end up with 35 times the amount of documents, but 35 times less fields, which is why this was green, because remember, this is well below the actual limits we have. This is something that's probably hard to implement. It was just an idea for Liferay. Maybe Liferay can one day fix this. It's just an issue with if you use a lot of locales and a lot of web content structures, but it's still an issue. They do improve in 7.0. Yesterday it was explained that they now have a table for multi-language fields. So this is the first step on the database side. Now they also have to fix their Elasticsearch index, and everything will be fine for now. We are out of time, so my last takeaways. Can you reuse built-in entities? In our case, we did end up using structured web content, and it did save us a lot of time. So we got our entity system itself up and running in about, a month or so, and had, 9 months left to actually migrate all this data into those structures. If you do write your own code, start from an early point of time, start thinking about how you deduplicate code. And finally, if you have some requirements where you actually have to query data, and, the database is not doing it very fastly, do think about using Elasticsearch. And that's for that. Our second talk will be immediately after the lunch break. So this will be going deeper into design decisions, our technology stack, and the actual migration. I recommend going there. It's in Blue Hall at 2:45. And for now, we do not actually have time for questions. So meet me at the unymira booth, or just write me an email, or wait for the second talk. Thank you very much. Do rate the session, and have a nice day.
Thank you, Chris. That was excellent.